here. 3 short. All right, let's start it. So 1f is inverse functions. Okay, it says if f is a one-to-one function, then we can find the inverse. Now remember, a one-to-one function, what that is, and I'll quickly explain it over here. Okay, one-to-one function. If we draw a graph very quickly, okay, let's say a parabola, a straight line, anything like that is a one-to-one because I can cut the graph for this one is not a one-to-one. For every y value, there is 1 to x value. So this is not one-to-one, but straight lines are all one-to-one because for every one x value, we get a y value, and vice versa. For every one y value, we get an x value. Okay, so that's what a one-to-one function is. So if it's a one-to-one function, then we can work out the inverse of it. Okay, a couple of things you need to know, right, or remember when you do this. Okay, to find the inverse, we first let the function equal y because it's in terms of f or g or h or whatever it is. So we can't say swap x and y if we don't say let the function equal y. And then once we do that, we can say swap x and y, and we don't have to say this, but that's our step we're solving for y. So example 7 says, find the inverse function f to the power of -1 of the function f of x equals 2x minus 3. Okay, so here I've said let f of x equal y, which equals 2x minus 3. You could say let y equal f of x, which equals 2x minus 3. It's probably better. And swap x and y. So I do. In the next question part of it, instead of y, I put my x, and instead of my x, I put my y. So I swapped them. And now I solve for y. So at the moment, I've got my 2y, and I'm going to do x plus 3. And then I divide by my 2. So I get y equals x plus 3. This is, of course, after I've done all that, letting the function equal y and writing swap x and y. If you don't do that, if you don't write swap x and y and let f of x equals y, you will not get the full marks. And therefore, the inverse function, write it. They didn't give it to us in terms of y, they gave it to us in terms of f. So the inverse of f equals x plus 3 divided by 2, what we just got. Now this is important. The domain of f here equals rules. The range of f equals rules. We know that because that's just a straight line. Done. Okay. What's even more important, that the domain of the inverse function equals the range of the function. Okay, so if you find your domain and range of the function, then the range becomes the domain of the inverse, and in this case it's just rules. The range of the function becomes the domain of the inverse. And I know that -1 is not properly, I don't know why I left it like that. So that means it's equal to rules. Any questions there? Okay, let me just clear this. Example 8. Example 8 says, find the inverse of these functions. State the domain and range if they exist. So I've got it, you guys, to do it. So I should give you some time to do it, but I won't. Okay, 1 divided by g of x, which equals 1 divided by 5 minus x. Now, in case some of you don't know what that graph looks like, that's fine. It does tell us that x has to be greater than or equal to 5. So if I was to quickly do that, just to have a quick graph, okay, x is 5. So at 5, we have an asymptote. So there it is there. That's at x equals 5. It doesn't say to sketch the graph. This is only me sketching it just to show you guys. Then let's do x equals to 6, because it's greater than or equal to 5. We put x equals to 6, we're going to get -1. So at 6, it's -1. At 7, it's going to be -2. So how does the graph look? So, 5, yeah, -2, so -1/2. So it ends up coming like this. Bad graph, but it ends up coming like that. So it's a one-to-one function. So that one does exist. Fantastic. So now we're going to work it out. So we're going to say let g of x equals y, which equals 1 divided by 5 minus x. We're going to say swap x and y. So we get x equals 1 divided by 5 minus y. So 5 minus y equals 1 divided by x. I'm going to move the y to the other side so it becomes a positive, and at the same time I'll move this to that side. So I get y equals 5 minus 1 divided by x. Any questions there? I haven't finished it, but any questions so far? Okay, so my g, and I'll rub this out, g to the negative 1 of x equals 5 minus 1 divided by x. I know my domain here for the function, that's my domain. My range for g of x is, can anyone tell me? Or you're all too scared to tell me the range? Okay, it's negative infinity.
It's real?
No, it's not real, because there's the range, there's my x-axis, and there's my graph.
Negative.
So it's from negative infinity,
Negative infinity.
to
Infinity?
0. To 0, the x-axis.
Does it touch 0 though?
Sorry? No, it doesn't touch 0. No, it does not touch 0. So there's my range from it, from negative infinity to 0. So writing my domain of the inverse, domain of g to the negative 1 of x, that equals the range of g of x. We just worked out that range. The range of g of x equals negative infinity to 0. The range of inverse of x, that equals the domain of g of x, and the domain of g of x was x being greater than or equal to 5. So I'm going to write it as, sorry, greater than 5. I'm going to write it as 5 to infinity. Both open brackets, not square brackets. Any questions there? Now,
what does that word say?
Which one? Here?
The one, you know, it says dom. Yeah, what does that say? Or Sam?
No, this says domain g to the negative 1
range.
of x, and the range. Yep. Sorry, my writing's a bit bad today. That's all right.
Good.
And I'm going to, because it's in a function. Yep. So another
I was going to say, what happened to the squared? Wasn't there a squared on the x?
No, that's
Wasn't it 1 over 5 minus x squared?
No, 5 minus x, that's a comma.
Okay.
Pick up, but it's a comma. And now I'm going to write it in function notation. So therefore, g, if I hit the keyboard, negative 1 of x, okay, such that the domain is negative infinity to 0 to the codomain, which is reals. Codomain is always reals. That is a g to the inverse. G to the negative 1 of x equals 5 minus 1 on x. So that's written in function notation. I'm going to rub all that out once you guys copy it down and do the next example. Okay. Can I get rid of it?
Nope.
Not yet. Okay, we've got one student short now. Don't know who's missing. Someone still writing? Okay, I'll get rid of it in 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Okay, let's do part B. Okay, again, the same thing. Before we can say swap x and y, we're going to say let h of x equals y, which equals x squared minus 2. I'm going to say swap x and y. I can't even remember if I wrote that for the first one. I'll get x equals y squared minus 2. Solving for y, I get y squared equals x plus 2, and y equals. Now, I'm going to write plus and minus the square root of x plus 2, because remember, when we take a square root, we have to do plus and minus. And now we have to work out which one actually exists. Okay, so we've got the domain. So when I graph this graph, and I'll do a quick graph over here, it's down to -2, it's been translated, and normally I would graph it like this. Okay, that's my y-axis, that's my x-axis. Since it's got to be from 1, when x equals 1, if I substitute in there, I get 1 squared minus 2, I'm down to -1. So when x is 1, it's -1, so that's where it starts. So really, this graph is only that part there, the red part. Okay? Any questions there? So the range of h of x is from -1, I forgot to put that in, 1, -1. It is from -1 to infinity. -1 inclusive to infinity. Okay, so when I look at that, all right, my inverse is going to have domain for h inverse of x is going to have domain of -1 to infinity, and it's going to have range from -1 inclusive to infinity. So really my graph of the inverse is going to be -1 is there for the x, -1 along the x, and -1 along the y. So my graph is going to be down here. Okay, so down there. That's what I can see. So I have to work out if it's a positive or the -1. -1 to infinity. So from that one,
the range is -1 inclusive or not?
it's inclusive because of that point right there. That is the point 1, -1, and it is inclusive because x equals 1 is inclusive there.
Okay, thank you.
Okay. All right, so doing all this, finishing it off, where's my drawing? I've got, and I know I haven't changed it there, but that should be h to the -1 of x, or equal the square root of x plus 2. Oh, I thought I went to blue. Come on. So my whole thing will be h to the -1 of x such that -1 to infinity, just in case you get asked, 2 reals. I'm not going to write it beside it because I'll run out of room. I'll write it underneath. H to the -1 of x equals the square root of x plus 2. Okay, that's that one. I don't remember to put more spaces in these. Someone's dropped out. Don't know who dropped out. All right, give you a bit of time to write it, and then we'll do some graphing part. Now, your textbook, if you've got the online one, if you don't, if you only get a PDF, of course you can't do this. But if you've got the online one, you can see videos of some of these questions as well. Okay, like the next one we're going to do the graphing, that's got a video attached. Some of them have, some of them haven't, but you can see videos. All right, can we rub that out? Okay, let me clear that one. Okay, some graphing. Okay, I might need to do that. Now, when we graph a function and its inverse, they are reflected in the line y equals x. Okay, that's what happens. So if I've got this dotted line here, which is y equals x, and I've got the red one, that's the function, then the inverse I can find because they will cross at y equals x. So you've got to get the mirror image of it. So you can say, right, pretend there's a mirror there, and say, right, this red one, this part over here is going to go underneath the line. This part over here is going to touch the y-axis on the other side. And then it's still going to continue with the loop. So we get that. Okay, then we've got this part over here. So it's reflected in it. So you try and find your reflection in that line y equals x. So that's one way to do it. If they ask you where do the function and where does its inverse intersect, well, really, you can just find the intersection of one on the line y equals x. So you can get the inverse and you can put it equal to y equals x, or you can get the function and put that equal, because they're reflections and that's where they intersect. Okay, let me just move it up a bit. So example 9. Okay, example 9 says find the inverse of the function f of x equals 1 on x plus 3 and sketch both functions on one set of axes showing the points of intersection of the graphs. Okay, so I found on the side here my intersection. I let f of x equal y, I'm swapping my x and y. I've rearranged it by subtracting 3. Then, I don't know who's doing that, there's a lot of noise coming through. By subtracting the 3, and then to find y, I just flipped it. So I flipped this one and I flipped this one. That's how I got my y equals 1 divided by x minus 3, just flipping them both. So there's my inverse. Okay, I know that this is a particular type of graph because it's 1 on x, it's a truncus, and it's been translated 3 units up. Okay, and I've sketched it all on the calculator. That's the blue one. So there's the line y equals 3. Okay, I should have put that in before. Y equals 3, that is an asymptote. And x equals 0 is an asymptote for the original one. Now so we can find our domain. Our domain is all reals except x equals 0, which it tells us there. And our range is all reals except, of course, y equals to 3 because of that translation. So the range here is reals except 3. So this range becomes my new domain for the inverse, there it is. And this domain becomes my new range for the inverse, there it is. Okay, so I found my inverse, it says sketch both on the one set of axes. Okay, well this one is still the same type of graph, except it's been translated 3 units to the right. So there it is, I'll change it to a yellow, hopefully that comes out. So 3 units now, x equals 3. We have our asymptote, and nothing happens, it's not translated up or down. So at y equals 0, we have our asymptote. And there's a new graph. It's still a truncus, nothing changes. Any questions there? Because then it says show the points of intersection of the graph. Well, the easiest thing is I put in the line y equals x. There it is, and that's where they intersect, only there. Any questions? If they asked us to find it, then we would have to find those intersections. I found them on the calculator, as you can see. Okay, it doesn't matter which way we do it, all 3 lines. The function, which is the blue one, the red one, and the y equals x all meet at that one point there and at that one point there. Questions at all? Okay, I'll clear it. Example 10. And I have you guys do it. It says express x plus 4 divided by x plus 1 in that form. Okay, as soon as it says that, you can see that the powers here for both of them in the numerator are 1 and in the denominator is 1. So we have to do our long division. Okay, that's the only way we can change it to this form. And as soon as we see that same powers in the numerator and the denominator, long division is the way to go. Now you can do the synthetic long division, it doesn't matter. I'm going to do the synthetic one. So x plus 1 equals 0 and x equals -1. So I put my -1 there. The number in front of the x in the numerator is 1, and then I've got the number 4. So I'm dropping my 1 times the -1 and the 1 becomes -1. Add these two together, I get 3. So in this form, I get x plus 4 divided by x plus 1 equals my 1 plus 3 divided by my x plus 1. Okay? If you do it the other long division way, you'll still get the same answer. So I found it. Then it says, hence, find the inverse of that function. So use what you've just found. And this is easier than to try and do that one there and find the inverse, because we're not going to have 2 y's as we do here. We're only going to have 1 y. So if I go, I'm going to find my inverse. So at the moment, I've got f of x equal to 1 plus, I should have said let y equals f of x, which equals 1 plus 3 divided by x plus 1. Swap x and y, so I get x equals 1 plus 3 over x plus 1. That plus should be a little bit further out. Should be there. Okay, so I'm going to take away, and that should be, of course, y there. Take away my 1, so 3 divided by y plus 1 equals x minus 1. Flip them both, so I get my y up the top. Times by 3 and subtract 1. So I'm going to get y equals times by 3 and then subtract 1. So there's my inverse. So the inverse, -1 of x equals 3 over x minus 1 minus 1. Okay, sketch both functions on one set of axes. Hopefully I've sketched them. Let me have a look. No, I haven't sketched them. Ah, okay. Can I leave them for you guys to sketch? Is that okay? I'm going to leave them for you guys to sketch. All right, let me clear this one and move to the next example. Okay, example 11 says let f be the function given by that. X, of course, is an element of rules. This is a truncus. How do I know that? Because it's got the x squared. And a truncus just means it looks like this all the time. As long as it's got an x squared and it's 1 divided by, it's a truncus. Okay, so define a suitable restriction G of f such that the inverse of G exists and find the inverse. So this is not a 1-to-1, because as soon as I get one y value and I go across, I hit an x there and I hit an x there. So not a 1-to-1. It has to be a 1-to-1 function. Okay, so I can restrict it. I can restrict to this domain and have just the positives, or I could have the negatives. Okay, doesn't matter which one. So here I've got one function where I've restricted the domain for just the positives, and function number 2 where I've restricted the domains for the negatives. Okay, but I'm using the f of 1, so only function 1, okay, to determine its inverse. So I've let it equal, I've swapped it, okay, I have now found it, there it is there. I know my range of the inverse is domain of the function, which is that, therefore I only need the positive one. So the domain of the inverse is the range of the function, which is that, and then I've just written it all as function notation. You could have done number 2, but it didn't matter. I've just used number 1. You can't just use the positive part only. Any questions there? Okay, that's 1F. Now remember, you're going to be receiving a few emails off me. It's just me converting from Zoom from here to Zoom using St. Monica's College so that we don't run out of time. Okay, you can just ignore them, and I will be putting them into your calendar, into your Outlook calendar. If I make a mistake, I'll, edit it so you'll get it again. So just be aware of that. Hopefully I won't make any mistakes. So I'll be cancelling all these ones first and then putting in the new ones. But has anyone got any questions? Okay, I'm just going to